Let's have a look at question 22. You can see a diagram there of a rectangle which has been broken up into smaller units. Two of them are called P's and two of them are called Q's. The question reads, rectangle ABCD is made up of 5 smaller disjoint rectangles. Disjoint means that they don't overlap. The 4 outer rectangles have the same area. So those are 5, the outer ones have the same area. The area of the inner rectangle is 1/2 that of the others. All right, so we'll just bear that in mind, that the center rectangle is half the area of the others. The width of each rectangle is 3, of P is 3. Let's just record that. P is 3. So this P is here also. So the width is 3. And the width of each rectangle of Q is 5. So you go from Q, and this is 5. Q is here as well. Okay, and the question is, find the area of rectangle, the large rectangle. Not much is given. All right, now let's we know that these 4 areas are the same. Now let's look at the area of P and Q. This area here is 5 times something. This area here is 3 times something, and they are both equal. Right, so if I make this X, this area here is 3X, and this area here is 5 times something equals 3X. That doesn't look too good. So I would rather not give the name X here. We've got the area is a sort of, it's a multiple of 3. It's also a multiple of 5 because it's 3 times something. And also, so to make this area a multiple of 5, we should put a 5x there. So instead of calling it X, we'll call it 5x, and you will see what happens. So this area is 15x now. And this area here, this area is also 15x. So this becomes 3x. Sorry. This side becomes 3x. The area is 15x. And this area is also 15x. So this is 5x. It's 5x. 3 times 5x. And you get 5. See, so there are no fractions here. This is great. And this area here is 1/2 the area of the others. So this is 15x over 2. So we have an equation now, namely the area of the rectangle. You can work it out in 2 different ways. It's equal to 3x this breadth times the length it's 5x plus 5 is equal to the sum of all these 4 areas. Well, this is 4 times 15x. All these outside ones, 15x, and this is 15x over 2. Okay, so this implies that if you got 3x plus 3, 5x plus 5, so that's 15 into x plus 1 times x plus 1 again, taking out 5 as a common factor. And here you have 60x 4 times 15 plus 15 over 2, or 15x over 2. That's the center area that I added. And you can see 15 is a common factor in both cases, both sides. So I'll divide by 15. And here you got x plus 1 times x plus 1. That's x squared plus 2x plus 1. X plus 1 all squared. So I'm dividing right throughout by 15. So I got 4x, because 15 goes into 64 times. And then here you have x over 2. Okay. I still got a fraction here. Okay, let's get rid of this fraction. We'll multiply by 2 right throughout. We got 2x squared plus 4x plus 2 is equal to 8x plus x. Multiplying right throughout by 2. Now you can bring all the x's to one side. You have 2x squared. This is 9x on this side, so it becomes minus 5x. 4x minus 9x. And this thing actually factorizes. It's x minus 1. Right. It's x minus 2 into 2x minus 1. If you expand this, you get 2x squared minus 5x plus 2 equals 0. So therefore, there are two values for x. X equals 2 or a half. So it looks as if there are two solutions, but the question says find the area as if there is only one solution. So one of these solutions is false, cannot work. So you have to figure out which one and why. Okay, so I suppose you can try it out, various things, but after trying out a couple, I can see here that this, you see, this is 3. So this is 3 on this side. That's the rectangle. So this whole thing is 3x. So you got 3x is greater than 3. 3x is greater than 3, which means that x is greater than 1. So this half is not acceptable. So therefore, x equals 2. Because 3x is greater than 3, obviously. Divided by 3, you get x is greater than 1. So you have to reject this first solution, second solution at least. So the question is find the area of the rectangle. The area is, okay, so you got 5x plus 5. Into 3x plus 3. And that is 15 into x plus 1 all squared. And substitute x equals 2. You get 15 times 9. 2 times 3 is 6 plus 3. It's 135. Okay, so this problem, the answer is 135. Let me go down to see what the actual answer is. I could have used this page here. All right, you can see right at the bottom with 135. Well, they call this thing a 10x. Yeah, because I think they want, I had a half at the end. So I put 5x. But if I put 10x, then I wouldn't have had the half at the end. Anyway, whatever it is, we come to the same answer. 135. Question 23. Positive integers are written on all the faces of a cube. So let's draw this cube then. So I'm going to draw this cube. Okay, now positive integers are written on all the faces of a cube, one in each face. Okay, there are 6 faces. So let's just give names to these. Faces. Okay, not names. We don't know what the integers are. So let's suppose we got A, B, C. Okay, those are the 3 faces that we can see. The 3 other faces on the, and then let's call this D. This under this. On this side here, which you can't see, let's say that the number E is written on that face, and there is a face at the back, which you can't see as well. Let's say that is F. All right, so these positive integers are written on these faces. At each corner, let's take this corner here. There are 8 corners, 4 at the top and 4 at the bottom. Product of the numbers on the faces meet at the corner in which it is written. All right, so here there are 3 faces which meet here. So at this point, you write the number ABC at the corner. So the vertex, so here you got ABC. Let's have a look at this. This is 3 faces, AB, there's ABE. There. Here, you've got C, and you got F on the other side and A. So you got ACF. Let me just look at the top 4. So you got A on the top there. On this side, you got E. On the other side, you got F. So it's AEF. All right. So you got those 4 numbers are written at the corners. And they say the sum of the numbers written at the corners is 2022. All right, let me just work out the 4 at the top. Sum of top corners. It's equal to AEF plus ACF plus ABE plus ABC. I'm simply writing those 4. ABE, AEF, AC here, and ABC. Those are the four. Okay, I think I can take out some common factors here. This is equal to AF. Let's take out AF here. AF into E plus C plus, that takes care of that AF. Here you got AB, which is a common factor, and this is also C plus E. Okay, so C plus E is a common factor. And you got AF plus AB is the other factor. So we can take out B plus F, and A is a common factor. So the sum of the four numbers at the top simplifies to something quite nice. Let's have a look. What is it? It's C plus E. So those two sides, B plus F on those sides, the whole thing is times A. I think I can work out what the bottom numbers are. Sum of bottom corners. Well, I don't really want to write it down. Okay, I can see I'm going to get C plus F again. And B plus E again. But this time, instead of multiplying the whole thing by A, you have to multiply this by D at the bottom. You can do it. You can work out what these numbers are at the bottom corners, factorize it, and this is what you will get. Okay. And the question is the sum of all the 8 numbers, sum of the numbers written at all the corners is 2022. So you got 2022. This is the year in which the paper was written. It's equal to the sum of these two things. And you'll see that C plus well, actually, you got C plus E. C plus E is the opposite faces. Those two opposite faces. And B plus F is those two opposite faces. And all that is being multiplied by A. So in this case, now you got D. And once again, you got the opposite faces. So you get exactly the same thing. It's actually C plus E to B plus F. So when you add these, you got C plus E plus B plus F. That's common. And it's into A plus D. That's, if you take this out, you get A, and if you take this out, you get D. So they ask you, what is the sum of the numbers on all the faces? So you've got this. The question is, what is A plus B plus C plus D plus E plus F? What is the sum? Now, at this stage here, I've got factorization. I've got 2022 has been factorized, and you can try to factorize 2022. And you'll see 2 goes into this 1011 times, and 3 goes into this. So you get 2 times 3 times 337. And it turns out that 337 is a prime number. You might have to check it out. But this is equal to this. So now this is interesting. It means that these 3 factors are the same as this. So let's write this thing as a set. The set of 3 factors is C plus E, B plus F, and A plus D. That set is the same as 2, 3, and 337. So the sum of all the faces is, if you add up all these 3, you'll get this. So this here is equal to the sum of all the elements in the set. But these 2 sets are equal, so it'll be the sum of all the elements of the other set as well. And you get 342. Very nice problem. So that is the solution to that one. We have 342. Okay. So let me just see what we've got here. There it is, 342. So it's just the sum of those 3 factors. All right, so that takes care of that one. So the next one is question 24.